Hi everybody, in this example we are going to look at power across an inductor at a given time increment. In this problem we're going to calculate the power across the inductor when t is equal to 500 milliseconds. That means we should start off by converting the time. Remember, milli is a prefix for 1 over 1,000, so we can write 500 milliseconds as 500 times 1 over 1,000 seconds. 500 over 1,000 is just a half. A half I can write as 0.5, so we have that our time is equal to 0.5 seconds. Now we're ready to look at the current through the inductor. We're given that the current is 8e to the negative t milliamps. As a reminder, e is a number. It's about 2.71828. You will find this number on scientific calculators, and I'll show you what that looks like. What we need to do is plug this value of 0.5 seconds into this function I of t. That means we want 8e to the negative 0.5. In this scientific calculator, I'm going to push 8. Then e to the x is a second function, so I have to hit second and then the key to get e to come in. Now, by default, it expects e to be an exponential function, so it knows we're putting something in the exponent, and we're putting in negative 0.5. Push enter. It's going to give you a bunch of decimals, but we're only going to grab 2. We're going to use 4.85 in our solution. A second choice for evaluating this function would be to use something like Desmos. Here I can type 8 and then E. Just with my regular keyboard, I need to do a caret to say go up into the exponent. I put a negative and again 0.5. I get the same 4.85. So whichever calculator you choose to use, you'll get the same answer. So our answer is 4.85 milliamps, and this time we want to leave our solution in milliamps. Next, we're going to find the voltage across the inductor at the same time of 0.5 seconds. This time we have 16 e to the negative t, and our unit is volts. Once again, we're just plugging in 0.5 for the t. That looks like 16 e to the negative 0.5. Let's go back to the calculator. I'm going to clear out my last entry. I'll type in 16, again push second, and e, and then I put negative 0.5. Push enter. It says it's 9.70449. I'm going to call that 9.70. Now that we know our current and our voltage, we're ready to figure out the power. To calculate the power across the inductor, we're just going to multiply the two values we just found, the current and the voltage. We want our answer in milliwatts, which is what we get when we multiply a milliamp times a volt. 4.85 times 9.70 gives us 47.05 milliwatts as our final solution.